Hello, everyone. Welcome back. So today we want to learn about the algebra of functions, explain what that means. And what that means is this is our goal to be able to add, subtract, multiply, and divide function, evaluate inputs using formulas and graphs. And then we'll also be able to find the domain of this new function we create by adding, subtracting, multiplying, and dividing functions. So the algebra of functions, algebra in general just means, here we're talking about adding, subtracting, multiplying, and dividing. And we can do that with numbers. We can also do that with functions because functions are essentially give us numbers just in kind of a more general way. So let's take a look at our rules here. And part of this is about learning what the expressions, what they look like and what they mean. So when you see something like this, f plus g of x, that means we're taking our functions f of x and g of x and adding them together. And since you can add in any order, this is the same as we did g plus f of x would be exactly the same. Okay, since you can add in any order. All right. And once again, we'll see this works whether we're talking about x, a variable, or a constant instead of x. Difference or subtraction, f minus g of x. Well, this means we take f of x or function f of x, subtract from it g of x. And here, since subtraction matters in general, subtraction also matters here. If we change the order, it's a different function, although only different by a negative. Here, and then the product of functions, f times g of x, just means we multiply the functions together. And once again, multiplication, the order doesn't matter. So this is the same as g times f of x. And finally, quotient functions, we're dividing the function f of x by g of x. And here, of course, g of x can't be 0 since we can't divide by 0. And also have to be careful about the places where g of x might be 0. And once again, since order is important in dividing, then the order here matters in this case. So let's take a look at some examples on the right, and we'll practice with this. So we're going to write down some functions we're going to use. So our function f of x is equal to the square root of x plus 2. We have a function g of x, which is equal to x squared plus 1. And finally, a function h of x, which is equal to 1 over x minus 1. Okay, so what we want to do is we want to find the following values. So number 1, let's say we just do f plus g of x. This is a g, f plus g of x. Let's do that first, and then we'll find a value. Okay, so once again, what this means is what the rule says. Look at this rule here. This says, if you see this, that means I'm going to add my functions together. F of x plus g of x. Okay, now if I add these two together, and actually, let's see, I think I may want to trying to decide. No, this is fine. All right, so I'm going to add these two together. In this case, it simply just means so f of x is the square root of x plus 2, and g of x then plus g of x, which is x squared plus 1. Now, in this case, you always want to combine your like terms like any kind of function, simplify it. In this case, there are no like terms, there's nothing to combine. So unless you just want to reorder the terms, this is our combined function. Okay, now let's say we want to find a value. Now, let's say we want to do f, let's say it this way. So I want to do f plus g of, say, 2. And what that means, I just replace x with 2 in this new function. Once again, stand back and say what we created is a new function with new properties. Okay, this is not the same as either original function. It's a brand new function, and an input into this function will be different than input into any of the separate functions themselves. Now, if I plug in 2, I just replace x with 2, and so that's going to be 2 plus 2 on the inside of the radical plus 2 squared plus 1. Of course, that's the square root of 4 plus 2 squared is 4 plus 1. Of course, the square root of 4 is 2. So I have 2 plus, I'm going to combine those plus 5. This is going to be 7. So this value plugged in. Now that I have my function, I plug in that value, and that is 7. Okay. This input of 2, my output is 7. Now, there's another way I can also do this. Okay. The other way, if I do f plus g of 2, is if I look at my rule, in my rule, I just replace x with 2. So this is going to be f of 2 plus g of 2. Okay. According to my rule, if I just replace x with 2 or x with any number. And so this is going to be, so f of 2, remember f was the square root of x plus 2, and g is x squared plus 1. And so we'll see this will give us the same thing. Square root of 2 plus 2 is equal to the square root of 4, which is equal to 2. Then g of 2, which is x squared plus 1, so it's going to be 2 squared plus 1, which is going to be 4 plus 1, which is 5. And then, as you can see, I squeeze this in, so f plus g of 2 is, as we saw up here, 5 or 2 plus 5 or 5 plus 2, the order doesn't matter, is equal to 7. Same thing. Okay, get the same result. So if you need to find, it simply says f plus g of x, you have to find that function, that new function. But if it says f plus g of 2, you need to find the function, for example, or f plus g of a single constant. You need to find the function value. You can find the function first, then plug it in. Or you can use the rule and plug the number into your functions individually, then combine those results, however it says. Okay, let's take a look at another one. This time, let's do g minus f of x. Okay. Actually, let me change that to f minus g, because there's something important to show you. So this will be different from g minus f. Okay. Now, our rule says this is going to be f of x minus g of x. And since the order's importance subtraction is here as well, and so we'd f of x, which once again is the square root of x plus 2, then minus g of x. Now, since I'm subtracting, remember g of x is x squared plus 1. So I need subtracting the whole thing. So I definitely need parentheses here because I'm subtracting the entire x squared plus 1. So be careful with that. Okay. Of course, then if we just distribute our negative through, that changes our signs there. It becomes x squared of x plus 2 minus x squared minus 1. So in this case, if I do, let's say then, if I want to do, for example, f, so let's do f minus g of, say, 3 this time. So I just plug 3 in for x. And so that's going to be the square root of 3 plus 2 minus 3 squared minus 1. Go through and simplify. So this becomes the square root of 5, and I can't reduce the square root of 5. And minus 3 squared is 9, so that's 9 minus 1. And so this becomes the square root of 5 minus 10. And that's the exact answer. Since I can't simplify the square root of 5 and I can't combine these exactly, that is the exact answer, though you can approximate this in your calculator if you want. Okay, then let's do the other way. Okay, if I do a second way, as I did before, f minus g of 3, and let's see, we get the same thing. My rule says that's going to be f of 3 minus g of 3. Okay, let me write a better f. All right, so in the same way, f of 3 is the square root then of 3 plus 2, which is the square root of 5. G of 3 is going to be 3 squared plus 1. Which is 9 plus 1, which of course is 10. And so that leaves me with f minus g of 3 is equal to square root of 5, then minus g of 3 minus 10, exactly the same result as we expected. Okay, so once again, for a constant, you can do this either way. You can either, as we did before, either find the function first and plug it in, or just want a constant, you want to just evaluate that constant, that number in each function first, then combine them with whichever rule you're using. Okay, number 3. And give me a moment to decide which one I want to do next. Okay, let's do h times h of x first. Okay, we haven't used h yet, so let's recall what h was. My function h was 1 over x minus 1. And this time I'm doing the algebra of the function with itself, which is perfectly fine. Okay, so our rule says this thing is going to be h of x times h of x, or in this case, times itself. And so that's going to be 1 over x minus 1 times 1 over x minus 1. Okay, remember, we're multiplying fractions, so multiply across. 1 times 1 is 1. X times 1 times x minus 1, I'm going to write it as x minus 1 squared. Now, we could multiply that or FOIL it out if you want, but it's perfectly fine to leave it like this. Okay, so let's do an example. How about we do, I'll say then, let's do h times h of 2. Okay, so that means I'll have my function plug in 2 for x. So 1 over 2 minus 1 squared. And of course, that's just going to be 1 over 1 squared, which is 1 over 1, which of course is just 1. Okay. So once again, by creating this algebra of functions, by multiplying my functions together, I get a new function with new properties. If I plug in a value, this is its value. Now, in the same way, I can do it the other way. And so that's going to be h times h of 1. I was going to use my rule that says it's going to be h of 1, using this rule here. H of 1 times h, or sorry, h of 2, rather, not 1, 2. Because actually h of 1 would be undefined. All right, and so if I do that, that's going to be 1 over 2 minus 1 times 1 over 2 minus 1. And of course, that's going to be 1 over 1 times 1 over 1, which, as you can see, will just be 1 over 1. And that's just going to give you 1 over 1, which is equal to just 1. Same result. Okay, let's do one more example. For 4, let's do a division one. All right, this time, let's see. How about we do g divided by h, or g divided by h of x. Okay, once again, by my rule, this says we have g of x divided by, that's the g, so this, let me rewrite that better, over h of x. Okay, now what's that going to look like? Well, it's going to look like this. So g of x, which is x squared plus 1, okay, over h of x is 1 over x minus 1. Now, don't worry about that, because remember, I did this on purpose to remember that when you're dividing with fractions, maybe you multiply the reciprocal of what you're dividing by. So this is the same as x squared plus 1 times, then the reciprocal of what we're dividing by, this is 1 over x minus 1. That's going to be x minus 1 over 1. Okay. Multiply by the reciprocal of what you're dividing by. And so as you can see, that's just going to be x squared plus 1 times x minus 1. Okay. And this, if you want to FOIL it out, you can. And so this then would be, if we FOIL it, x squared times x is x cubed. Outer term is x squared times negative 1 is negative x squared. Inner term is plus 1 times x is plus x. And finally, last term is plus 1 times negative 1 is negative 1. Okay, that's our new function. Now, in the same way, if I do g divided by h of, should I pick? Let's just pick something simple. Let's pick 1. Let's find out what happens. Actually, no, let's not pick 1, because actually that's going to cause a problem. So let's pick 2. So make it easy on us. We're just trying to show how this works. And so, of course, what I do then is I just plug that into my function. So 2 cubed minus 2 squared plus 2 minus 1. Okay, 2 cubed is 8. Minus 2 squared, of course, is 4. Plus 2 minus 1. Order of operations go from left to right. 8 minus 4 is 4. Plus 2 minus 1. And so that's going to be 4 plus 2 is 6. Minus 1. This whole thing then is 5. Okay. All right. Now, let's do the other way for a constant. And the other way says if I have g of 2 divided by, or g of 2, write it this way first, g over h of x 2, my rule then is going to be g of 2 over h of 2. So if I do that, then g of 2 is going to be 2 squared plus 1, which you know is going to be 4 plus 1, which is equal to 5. And then h of 2 to be 1 over 2 minus 1, which is going to be 1 over 1, which is equal to 1. So, as we'll see, we get the same thing. We have g over h2 is going to be 5 divided by 1, which is just 5. So you get exactly the same thing. Okay. So now we understand how to do algebra of functions using functions, and also if we have to evaluate them using inputs. Now, what if we have something different? What if we actually, instead of having the equations or the formulas for the functions, what happens if we have a graph? Let's take a look at that example. All right, so let's say we have this graph. I can move it around. All right. Okay, so we have, again, is this graph. And what we want to do then is use this graph and help us answer these questions below. Okay, so this time we don't have the formulas or the equations for the functions. We have to use the graph. Let's see how this works. We'll see it works kind of like what we've just been doing. So first off, let's do part A. Part A says f plus g of 2. And once again, our rule says that's going to be f of 2 plus g of 2. Okay, now let's take a look. So f of 2, so what we're going to do is find 2 on the x-axis, which is right here. Then here, our red curve is y as f, our function f. Our blue curve is our function g. So f of 2, we go to 2 on the x-axis, and we go up to meet the red curve, which is f, and the y-coordinate of that point, when x is 2, on that curve, y is 2. So that is our value f of 2. Then g of 2. So we go to, once again, go to where x is 2, and go up to meet the blue curve, and when x is 2 on that curve, y is 1. This is 2 plus 1, which is 3. And since the order doesn't matter, if we did g plus f of 2, we get the same result. Okay, part B. B is another similar one, so f plus g of 4. Once again, from our rule here, it's going to be f of 4 plus g of 4. Okay, so do it the same way. So when x is 4 right here. So in the red curve, when x is 4, go to meet the red curve, y is 1. It's going to be 1 plus, do the same thing for g. So when x is 4, then go down to meet the blue curve, which is g. When x is 4, y is negative 3. Plus a negative 3, so 1 plus a negative 3 is negative 2. All right, so part C, these all work basically the same way. So f minus g of 6. Okay, so our rule says that's going to be f of x minus g of x. So in this case, f of 6 minus g of 6. We do the same thing. When x is 6, okay, meet the red curve, which is right here. When x is 6, on the red curve, y is 0. And minus, then, let's go when x is 6, go to meet the blue curve, which is g. When x is 6, g is 1, positive 1. This is 0 minus 1, which of course is negative 1. Okay, let's do part D. Now, part D, if you notice, is just reverse. So we said this is going to be different because order is important when it comes to subtraction. As we'll see, what we actually expect it should be is only different should be the different sign. Okay, we have the same essentially values for f of 6 and g of 6, but we're reversing them, so our final sign should be different. So this was negative 1, so let's see that. We already have these values. We know that this is from our rule. This is going to say g of 6 minus f of 6. We already have those values. G of 6 is 1 minus, then f of 6 was 0. That's right. The only difference here is just positive 1 instead of negative 1. That's the difference between when you switch the order, then it flips the sign. Okay. 2 more of these. Part E, f times g of 2. Once again, from our rule, this says f of 2. This is f of 2 times g of 2. All right, same thing we were doing before. Where you found these values before, but when x is 2, then on the red curve, which is f, when x is 2, y is 2. And then when x is 2, g is 1. So that's going to be 2 times 1. And we found the same values right here for part A. That's going to be 2 times 1, which is just, of course, 2. All right. Then part F, and this is a division example, f divided by g of 4. Okay. It's going to rule says this is f of 4 divided by g of 4. Okay. Which we can do as long as g of 4 is not 0. Okay, so let's find these values. We found these values before, but let's check them again. So when x is 4, go to where x is 4. On the red curve on f, when x is 4, f is 1. And when x is 4, g is negative 3. This is 1 divided by negative 3. Double check that again if you need to. So when x is 4, f is 1. And then when x is 4, g is negative 3. So of course, you can't just leave it like that, or if you put a little negative out front, that's perfectly fine too. Now, if we did one more, if we did the reciprocal of this, g divided by f of 4, we would find its reciprocal of that. So it would actually be negative 1, negative 3. Okay? All right, let's take a look at one more topic. I want to find the domain of let's say domain of a function. I'll say of the result of algebra. Okay, and what I mean by that is this is what we're doing here. So as I said, we do these function operations called function operations or algebra of functions. We create brand new functions with new properties. Now, there is kind of a more mathematical way of explaining what the domain is, but I think the easiest way to do it is being consistent with what we've done in the past or done before, you may have seen before. So I've also done a video on finding the domains of functions. So if you haven't seen that, watch that video, but let's do a quick one, explain how this works. Let's actually say, let's go back and look at our functions we started with. Let's do F and G. Let's say I want to do F times H. Okay, so I want to find the domain of F times H of X. Okay, so F times H of X, remember F was the square root of X plus 2 and H was 1 over X minus 1. So remember, think of this as these are fractions, multiply straight across. And so our combined function, our new function, the square root of X plus 2 over X minus 1. All right. So remember, in general, when defining the domain of function, your function, the domain has to exclude or not include any values which make the function imaginary. That's when it result of taking the even root of a negative number, particularly the square root of a negative number, or undefined where you're dividing by 0. We have to avoid both of these. Okay. Now, let's take a look at a few things. So if you notice, as far as dividing by 0, X can't be 1. Okay. So to avoid dividing by 0. Okay. So if you look at this, if X is 1, your denominator is 0, so I have to avoid that. Okay. Then, since we have a X under square root, it's possible this could be, we could end up having a negative number. If X is certain values, we have a negative number under the square root. So to find, I'll say the rest of the domain, or let me say, let's have that to put this way, to avoid imaginary numbers. What we want to do is solve what's under the radical is greater than or equal to 0. Okay, so X plus 2 is greater than or equal to 0. Okay, what I want to solve that is as long as what's under the radical sign is either 0, the square root of 0 is 0, or as long as it's positive, then that's okay. It just can't be negative. All right, so to avoid imaginary numbers, let's do this. And so all we have to do is subtract 2 from both sides. So this gives us then that X is greater than or equal to negative 2. Okay, so we have two things we have to avoid. X has to be greater than or equal to negative 2, and X can't be positive 1. So to do that, let's draw a number line to help us out, find our domain. Here's 0, here's negative 2, here's 1. Okay, now we know we can't include 1 because 1 would make it imaginary, so put open circle there. Now negative 2, we said X has to be greater than or equal to negative 2, so it's okay if this is equal to negative 2. If X is negative 2, what's under the radical sign is 0, and that's perfectly fine. The square root of 0 is 0. It can't be anything less than negative 2. It has to be everything here, but we can't to the right of negative 2 except 1. Okay, so it can be larger than negative 2, but once again, we said also that X can't be 1 to avoid being undefined. And so what we have here then is our domain is made up of two separate intervals. okay, from -2 to +1. -2 is included, -1 is not. And then from +1 to infinity, of course, infinity is never included, and also in this case, negative or zero, +1 is not included, and finally the union in between. So that's your domain. So you find the domain of these new functions, result of these combinations, the same way you found the domain of any other function. And that avoids having to come up with new rules. Simply remember that. Okay, so to summarize what we learned today is how to do what's called the algebra of functions, sometimes called function operations. Adding, subtracting, multiplying, and dividing functions. We learned how to do that in terms of the functions themselves, in terms of finding specific values, using both the equations or formulas of the functions, also using functions and graphs. Then finally learned how to find the domain, these new functions, which is the same way you find the domain of any functions. Thank you. Have a good day.